Greetings, Earthlings. Well, continuing now with this HP attempted repair on this HP 34703A, I have removed successfully the Magic U7 hybrid, or whatever you want to call that. There it is. Desoldered that. And in its place, I have put these socket pins. So that I can lift the legs those are the ones for the first test that I've decided to lift, if you can see that there. I can lift the legs and do some tests. But first of all, let's look with no chip in there, chip or whatever you want to call that, hybrid or whatever. So all of the, okay, wait, back up. Recall. We've got a situation where we have zero input out here and reading at test point 1 minus whatever it is, 3.8 volts or something like that, 3.9 volts. So test point 1 goes to each of these switching FETs, and that's really the only things it connects to, besides this input protection circuit, which we've already looked at and corrected because it had a bad diode in it. So with no FETs at all in there, we should see 0 volts there. Of course, with the working chip in there, we should see 0 volts there, but we don't. So it appears that is coming through one of these FETs as a bad junction somehow that's putting possibly minus 12 onto there, and then it's being limited by the input protection circuit, which would be well, nominally 3.16 volts plus a diode drop, which gets you to about 3.8. Okay, so what I'm going to do, so I'll go ahead and plug it in. And I've got the shorting bar there on the input. Oh, one other thing. While we're talking about, when we're looking at these inputs, I did notice one issue with these replacement collets that I've got. The binding posts that are in there, which, I mean, I posted the HP part number. Have this knurled section where it goes into the collet. The collet, if you can see it, is made for this kind of connector, which doesn't have a knurled but just has a keyed edge there. So that's going to require possibly boring out the collets on the lathe to get them to fit when I go ahead and replace that. But that's a down the road problem. Only if we can get it working do I need to worry about that. All right, so it's plugged in. You'll be able to see the display. And then we'll measure the voltage here and read it on the Keithley there. Hopefully nothing blows up. Turn it on. It's still showing overflow. I'm in volts. I'm in auto. It's still, that's interesting. Test point 1 reads 0 volts. Test point 2 reads 0 volts. Why am I seeing, oh, there's 0. And there's 1. That was weird. Well, I do have 0 volts there. Okay, so there could be other problems as well. That'll be fun. So the next thing to try is to go ahead and, like I said, lift the legs. Now what I'm going to do, we've got 4 of them. I'm going to like divide it in half, but not this way. It's going to be sort of, I am going to lift the legs on this one, which is a current selector, because we did notice that the current overload protection circuit was blown. So there's some possibility that that got blown in the process. And I'm also going to lift the 1,000 volt legs. And it's 2 legs of each one because they have a common one, which is pin 13. So I can't lift that one, or I would lift all of them at once. So pins 15, 16, 18, and 19 for the first test. All right, well, it's kind of there. Boy, those pins are rather delicate. I'm not so sure that if I get a replacement, should this turn out to be the problem, which it will, I'm sure, if I'm able to find a proper, OEM replacement, I'm not sure I want to have those socket pins there. I may want to pull those out and solder it directly back in. But it's mostly set in there, I think. So we're on 0 volts, 0 volts, and again it's gone to overload. And we'll check. Test point 1 has minus 2.9 volts. Test point 2, minus 12 volts. Okay. So, now I got to pull it out, bend some more leads, and plug it back in. Such fun. Okay, I lifted 14 and 17 this time, which are this other input selector. So I have only on the input side, I have only this JFET still in place. On the other side of that JFET, all whatever it is, there are 10 total, so there's 6 of them out here, E through J, and they're all still connected, but unless that is on, nothing can go through there. So, well, we'll see. We'll see. That would be on. That would be on if we're measuring voltage, because it's got to pass through here. So, well, let's see what happens. Okay. Powering on. -1. Overflow, in other words. Test point 1. -2.8, and I have 2.9. Test point 2. -12. Okay. So, it looks like there's a problem on the other side. Well, either this JFET itself, or something on the other side. Because that, like I said, that JFET is on. Let me take that one out, and we'll put these back and see if at least up to here it looks okay, and then we can work on the other side of it if that turns out to be the case. Okay, I now have pins 9 and 12 lifted. That one, and all these others are put back. So, power on. Well, that's different. Okay. Now we're getting nowhere. Let's look at test point 1. minus 3.8 volts. Test point 2, 0 volts. Okay. So here, this is 0 volts, and we get random readings, which may mean that that's not actually grounded, but it's just floating. So I can try grounding that and see if we get a 0. But we've got minus 3.8, so well, that's weird, isn't it? This is like maybe this transistor could be bad. Okay. And it'll be coming this way. But then one of these apparently is also bad. Because we're getting the minus 3.8 here. Whereas when all of them are out, we get 0 there. And we get 0 over here, which says that the 12 volts minus 12 or minus 4 or whatever it is not coming this way through it. It could only be coming through it this way. So let me go ahead and ground TP2 and see if I blow it up. No, if I get a reading of 0. Here's a clip lead. There's TP2. Power on. Yeah. Yeah, so that's just floating. So that, I mean, that's pretty close. It needs to be calibrated. Okay, so that says to me that probably the other half, the right-hand half of the schematic, everything's okay. That we have problems here on the what's the left side if it's all folded out, because it's like multiple folds. You can almost see the folds here. And it looks like we have 2 problems. And so now I have to figure out which one or more of these is bad. All right. So I have now 9, 12, 15, and 16 lifted. Let's see what happens. Random. Test point 1. .5 volts, that's different. Test point 2 doesn't matter. Test point 1. 0.5 volts. Well, that was different. Why is it positive voltage this time? Oh, now it's 0.8 volts when I switch to manual. I'll put this to sleep. Okay, so as not to confuse the auto range circuit, that's pretty close to 0. It's bouncing around a little. I'm not sure why, but so it does look like that those 2 transistors are bad. So at this point, I would say we have identified the hybrid as a problem, And so I either need to find another hybrid, whatever you want to call that, 0813-0031 HP part, or I have to implement a workaround. Okay, I want to try one thing before I proceed, and that is to see if these dividers are actually working. What I'll do is I'll put 1 volt in, and then on the, because it lets me select the ranges, so I should see 1 volt coming through on the lower ranges, and as I go higher, like on the 10 volt range somewhere. Well, it's got a multiplier out here, so but at any point, in any case, at some point I should see it divided down by 100 or 1,000 or something. So there's 1 volt in. Here's powered on. Let me go back. And here's test point 2 zeroed out. And we're on the 1,000 volt scale, and if I measure test point 1, ooh, I got a nice little hole, and I can just lock that into. Okay, I will see what? Test point 1. Well, I'm seeing 0. I don't know. 0.009. Yeah, okay. It's too low. It's too low. Okay, so here's on the 100 volt scale. I see, there it is, 10 millivolts. 10 millivolts. And if I then go to the 10 volt scale, it's still 10 millivolts. When I go to the 1 volt scale, it's like 1 volt, 0.994. Yeah. And if I go to the 100 millivolt scale, it should bounce me back to, no, it doesn't. Okay. Oh, it doesn't know any better. Yeah. Okay. So on the 1,000 volt scale, I've got 1 millivolt. On the 100 volt scale, 10 millivolts. On the 10 volt scale, also 10 millivolts, and it would change the multiplier. And on the 1 volt scale, it passes straight through, and I get 1 volt. Okay. So, yeah, that tells me, I believe, that these transistors are good, these switches, and well, no, we don't know. We don't know. Well, it looks like everything, okay, it looks like everything on this side of the circuit is good. It's just those 2 transistors that are bad.